This video covers section 8.1, solving quadratic equations by completing the square. Our goals in this section are to solve quadratic equations using the square root property, to solve quadratic equations by completing the square, and then to use quadratic equations to do some application problems. We're going to start with the square root property, which is something that you've probably seen before. For starters, let's try to solve x squared equals 16. You can probably solve this by inspection. We're looking for a number that when it's squared equals 16. That number has got to be 4. However, there's one other possible answer. Negative 4 multiplied by negative 4 is also 16. So we're going to end up with these two answers. If we hadn't happened to notice that 4 squared equals 16 and negative 4 squared equals 16, we might have taken the square root of both sides of this equation to find out that number 4. Remember that the square root of 16 is 4. However, that doesn't quite get us our two answers, both 4 and negative 4. So a lot of times we add a plus or minus in front of the square root, indicating that we want both the positive square root and the negative square root, so that we'll get both of our answers. In math terms, we would say if a squared equals b, then a equals plus or minus the square root of b. In other words, the square root property says that you can take the square root of both sides of an equation in order to solve it. Just don't forget the plus or minus. Let's do a couple of examples using the square root property to solve an equation. Here I have 5x squared minus 55 equals 0. Now I'm not ready to take the square root of both sides yet. First I need to get the x squared by itself. So I'm going to start by adding 55 to both sides of the equation. Now I have 5x squared equals 55. My next step is to divide both sides by 5 so that I finally have the x squared all by itself on one side. So x squared equals 11. Now that I have the x squared by itself on one side, I'm ready to take the square root of both sides and write that my answer is x equals plus or minus the square root of 11. Now the square root of 11 isn't particularly nice, so we'll leave it in this exact form. Now let's look at another example. This one says x plus 2 squared equals 25. So I have some stuff that's being squared and it equals 25. That means I'm already ready to take the square root of both sides to undo that squaring. When I take the square root of both sides, the square root here undoes that squaring, which leaves me with just the stuff that was being squared, or x plus 2. Same stuff. And that equals plus or minus the square root of 25. Now, the square root of 25 is actually a nice number, so we can reduce that a little bit and make this x plus 2 equals plus or minus 5. At this point, for my own sanity, I like to break this down into two different equations. So one of my equations is saying x plus 2 equals 5. And the other equation is saying x plus 2 equals negative 5. This is how I'm going to get my two answers. For my first equation, x plus 2 equals 5, I can subtract 2 from both sides, which gives me x equals 3. My second equation, I'm going to do the same steps, subtract 2 from each side, but this time x equals negative 7, since negative 5 minus 2 is negative 7. And there's my two answers. Now here's two similar problems for you to try solving. Go ahead and pause the video and give these a shot, and then come back when you're ready and we'll talk about them together. And we're back. Let's take a look at these two problems together. Here I had x squared equals 20. Notice that the thing that is being squared is already isolated, so we can jump straight to taking the square root of each side. That gives me x equals plus or minus the square root of 20. Now this is completely correct, but you might notice that we can simplify the square root of 20 to be 2 times the square root of 5. So my final simplified answer is plus or minus 2 times the square root of 5. In my second example, I had 2x plus 1 squared equals 9. The squared thing is already by itself, so I can go straight to taking the square root of each side. That leaves me with 2x plus 1 equals plus or minus 3, since the square root of 9 is 3. Now I'm going to break that down into two equations so that I can finish solving for x. I have 2x plus 1 equals 3, and 2x plus 1 equals negative 3. Each of these equations are pretty easy to solve by themselves. I'll subtract 1 and then divide by 2 to get x equals 1. And the same process over here, but when I subtract 1, I get 2x equals negative 4, and when I divide by 2, I get x equals negative 2 as my second answer. You may have noticed that two of those examples weren't quite like the other. X plus 2 squared equals 25, and 2x plus 1 squared equals 9 isn't quite the same thing as x squared equals 20, or x squared equals 11. These two examples were in what we call completed square form. The process of taking a quadratic equation from standard form to this form is called completing the square. Remember, standard form is when it looks like ax squared plus bx plus c equals 0. Once you complete the square, you'll have something that looks more like this. A number times x, maybe plus another number, squared, equals some other number. If you happen to be reading ahead and have noticed that we're going to talk about the quadratic formula, I want to tell you that yes, our answers will be the same whichever method we use, whether we use completing the square or the quadratic formula. Most students find that they prefer one of the methods over the other. One of the steps in completing the square is finding the magic number to add to both sides of the equation. For example, what number could we add to this expression to make it into a perfect square? We're going to do a little bit of experimentation to find out. When we say that we want x squared plus 6x plus some number to be a perfect square, that means we want it to factor into two pieces that are exactly the same. Since my first term is x squared, I know that my first two terms will be x and x. Now, my last two terms have to add together to be 3, but they also need to be exactly the same number. The only number that adds to itself to be 6 is 3, which is half of 6. I'm going to put my 3's here. Now, multiply this back out, and we'll find out what our magic number needed to be. When I multiply it out, I get x squared plus 3x plus 3x plus 9, which is 3 times 3. So my magic number here is 9. X squared plus 6x plus 9 will factor back out to be x plus 3 multiplied by itself. Now let's think back through that mental process for just a second. To get that magic number, the first thing I had to do was take my 6 and divide it by 2. Then I took the number that I got and I squared it. I multiplied it by itself. And that gave me 9, since 6 divided by 2 was 3, and 3 squared is 9. If you remember that the coefficient on the x is usually labeled b, we could have rewritten this as take your middle term, b, divide it by 2, and then square it. And that's the formula for the magic number. Not too bad, right? Take your middle term, b, divide by 2, and then square it. That gives you the magic number. Now that you know how to find the magic number, we're going to look at the whole entire process of solving an equation by completing the square. The first step is to make sure that the coefficient on the x squared is just a 1. If it's not, we'll divide. Then you're going to subtract the constant over to the other side of the equation, so that you have just the x squared and the x guy on one side. You'll look at the coefficient of x, divide by 2, and square the result. That's your magic number, so you find the magic number. Then you add the magic number to both sides of the equation. The example that I have here, the first two steps have already been done. The coefficient on x is just a 1, so I don't need to worry about this. The constant is already over on the other side, so I just have x squared and x stuff on one side and a number on the other side. Now I find my magic number. I take my b, which in this case is 8, and divide it by 2 to get 4. Then I take that number 4 and I square it, which gives me 16. 16 is my magic number. Now I add the 16 to both sides of the equation. That gives me x squared plus 8x plus 16 equals negative 15 plus 16. On the left-hand side, notice that this is now a perfect square. When I factor it, it will factor as x plus 4 times x plus 4. On the right-hand side, negative 15 plus 16 is just the number 1. Now, x plus 4 times x plus 4 is x plus 4 squared. Now this should look like those examples we had that were in completed square form. At this point, to finish solving this equation, I can take the square root of both sides, which gives me x plus 4 equals plus or minus the square root of 1. But the square root of 1 is just 1, so this is x plus 4 equals plus or minus 1. Finally, I'll break that down into my two equations. X plus 4 equals 1, or x plus 4 equals negative 1. And then I can finish solving these. When I subtract 4 from both sides, I get x equals negative 3. And here when I subtract 4 from both sides, I get x equals negative 5. Those are my two solutions to this equation, and I can always check that by plugging them back into the original equation. So just to recap, the first thing that we did was made sure that this was in the right format for completing the square. We made sure that the coefficient on the x squared was a 1, and then we got the constant off to it by itself so that we had just x squared and x on this side. Then we found the magic number and added it to both sides of the equation. That made it so that one side factored into a perfect square, while the other side was just a number. Then we solved using the square root property, took the square root of both sides, and then finished solving to get our two answers. This process can be a little bit overwhelming at first, but with a little bit of practice you can get the hang of it. I'm going to do a couple more examples, and then I'll have a couple examples for you to try. My first example here is 5x squared minus 10x equals 15. Now, the coefficient on the x squared is not a 1, so that is the very first thing that I need to deal with. What we'll do is divide everything by 5 to get the coefficient on the x squared to be just a 1. Remember that that means I need to divide every single term by 5. That'll leave me with x squared minus 2x equals 3. My second step is to make sure that the constant is on one side by itself, while the x squared and the minus 2x are on the other side. And sure enough, that's true this time. The x squared and the x term are by themselves over here, while the constant is on the other side away from them. Now we find the magic number. I take the negative 2, which is the coefficient on x, divide it by 2, and then square whatever I get. Now negative 2 divided by 2 is negative 1, and negative 1 squared is just a nice positive 1. Now we add that magic number to both sides of the equation. I'll have x squared minus 2x plus 1 equals 3 plus 1. Now I factor the left-hand side of my equation. X squared minus 2x plus 1 factors as x minus 1 multiplied by itself, x minus 1. And on the right-hand side, I have a 4. By the way, if you notice that this minus 1 is the same as what I got when I took b and divided by 2, you're not wrong. That pattern is always going to hold true. My last step now is to use the square root method to solve. I have x minus 1 being multiplied by itself. So x minus 1 squared equals 4. Now I can take the square root of both sides, which gives me x minus 1 equals plus or minus the square root of 4. However, the square root of 4 is actually a nice number, so this is x minus 1 equals plus or minus 2. Finally, I break this down to be two separate equations. I have x minus 1 equals positive 2, or I have x minus 1 equals negative 2. Then I finish solving each of those equations individually. I'll add 1 to both sides, which gives me x equals 3 as one of my answers. And then I will also add 1 to both sides on my other equation, giving me x equals negative 1 as my other possible answer. Again, you could always plug these back into the original equation to make sure that your answers are correct. Now that we've run through that example, let's do one more. Here I have 3x squared minus 12x plus 2 equals 0. The first thing I do is check to see that the coefficient on x squared is 1. It's not though, it's 3. So I'm going to need to divide everything by 3 to fix that. Remember, that means I'm dividing every single piece of my equation by 3. That gives me x squared minus 4x plus 2/3, that's not going to simplify, and then 0 divided by 3 is just 0. Step 2 is to get the constant by itself on one side, leaving the x squared and the x term by themselves. So I'm going to subtract that 2/3 to the other side of the equation. That gives me x squared minus 4x equals negative 2/3. Now I find the magic number and add that to both sides of the equation. My magic number is negative 4 divided by 2, quantity squared, which is negative 2 squared, which is just 4. There's my magic number. I add that to both sides of the equation. Now I factor the left-hand side of my equation. X squared minus 4x plus 4 factors as x minus 2 multiplied by itself, x minus 2. And negative 2/3 plus 4 is the same as 10/3. Now we're all ready to use the square root property to finish solving this problem. I have x minus 2 squared equals 10/3. I'll take the square root of both sides, leaving me with x minus 2 equals plus or minus the square root of 10/3. Now, the square root of 10/3 is not actually a pretty number, so we're going to leave it like this in its exact form. However, the x isn't quite by itself either, so I'm going to add 2 to both sides. That'll leave me with x equals 2 plus or minus the square root of 10/3. And there are my two answers, 2 plus the square root of 10/3 and 2 minus the square root of 10/3. We could plug those into the calculator to get a nice decimal approximation, but typically we prefer to leave our answers in their exact format. Now it's your turn to try solving a couple of problems by completing the square. Go ahead and pause the video and then try following those steps for solving by completing the square on these two equations and see how it goes. And we're back. Let's take a look at these two problems together. My first example was x squared minus 8x equals 9. My first step is to check that the coefficient on x squared is 1, which it is. My second step is to get the x squared and the x on one side and the constant on the other side. But we already have that, so great, second step taken care of. Third step, find the magic number. So I take my b term, divide it by 2, and square it to get 16. Then I add that to both sides of the equation. Next, I factor. So x squared minus 8x plus 16 factors as x minus 4 times x minus 4, and the 9 plus the 16 simplify to be 25. Now I have x minus 4 squared equals 25. I'm ready to solve this using the square root property. Take the square root of both sides and get x minus 4 equals plus or minus 5. That breaks down to give me two answers. Either x minus 4 is 5 or x minus 4 is negative 5, which means that either x is 9 or x is negative 1. And there's my two answers for that question. In my second example, I have 2x squared plus 12x minus 4 equals 0. And this time, my first two steps aren't taken care of for me. First, I need to get the coefficient of x squared to be a 1. In this case, that means I need to divide everything by 2, so that I get x squared plus 6x minus 2 equals 0. Now I want to get the constant on one side and the x squared and the 6x on the other side. So I add the 2 to both sides. Now I have x squared plus 6x equals 2. Step 3, find the magic number and add it to both sides. In this case, my magic number was 9, so I add that to both sides of the equation. Now I factor. My left-hand side factors as x plus 3 multiplied by itself, or x plus 3 squared. And on the right-hand side, it's simplified down to 11. Now I'm ready to use the square root property. X plus 3 equals plus or minus the square root of 11. The square root of 11 doesn't simplify, so to finish writing our answer, I just subtract 3 to both sides, leaving me with x equals negative 3 plus or minus the square root of 11. Before we move on to a couple of application problems, I want to show you one more example, this time where the magic number is a fraction. The directions say solve by completing the square, and my equation is 3x squared plus 9x equals 12. So my first step is to get the coefficient of x squared to be 1. So the first thing I'll do is divide all three of these terms by 3 to make that actually correct. And that gives me x squared plus 3x equals 4. The next thing I want to do is make sure that the x squared and the x thing are on one side and the constant is on the other. Fortunately for us, that's already the case. X squared plus 3x equals 4. So I can move right on to my next step of finding the magic number. So I take my b, which is 3, divide by 2, and then square. Now, 3 divided by 2 isn't actually a super nice number, so we're going to make this, we're just going to go straight to squaring and make this 9/4 as my magic number. So I'll go ahead and add that to both sides. So I add my 9/4 to both sides. Now I'm going to take a moment and just simplify the right-hand side. 4 plus 9/4 is 25/4. And on the left-hand side, I have x squared plus 3x plus 9/4. Now, if we just handed you this problem and just started with this one, your reaction would probably be to try to clear the fractions by multiplying everything by 4. And that's exactly what I'm going to do right now. I'm going to multiply each piece by 4, which will clear the fractions. Notice that 4 times x squared will become 4x squared. 4 times 3x will become 12x, but 9/4 times 4, the 4's cancel, and I'm left with a 9. Here, 25/4 times 4, the 4's cancel, and I'm left with a 25. Now we're ready to move on to our next step of factoring, now that all the fractions are gone. I look at my left-hand side, and I happen to notice that it factors as 2x plus 3 multiplied by 2x plus 3. If you don't see that right away, that's okay. You can always go back and use the a times c method, maybe do a little scratch work off to the side to get that to factor. So now I have 2x plus 3 squared equals 25. It's time to go ahead and use the square root property. That leaves me with 2x plus 3 is plus or minus the square root of 25. But of course, the square root of 25 is actually a nice number, so 2x plus 3 equals plus or minus 5. Now we split that apart into two separate equations so that we can get both of our answers here. Either 2x plus 3 is 5, or I could have 2x plus 3 equaling negative 5. So I'll solve both of these equations. My first step is to subtract 3 from both sides. So that gives me 2x equals 2, and then divide by 2 for x equals 1 as one of my answers. On this one, I subtract 3 from both sides, and that gives me 2x equals negative 8. Then divide by 2 to get x equals negative 4 as my other possible answer. This problem really wasn't that different from the other problems that we did. It's just that our magic number came out to be a fraction, which meant that we had to sneak in this one extra step of clearing the fractions to make our life a little bit easier. Before we go, we're going to look at two examples of application type problems. You may know that when you're investing money, you're earning compound interest. The formula for compound interest is A equals P times 1 plus R to the T, where A is the amount in the account, P is the principal, R is the annual interest rate, and T is the time in years. We're going to use this formula to find out what interest rate I would need to earn $15,000 over 2 years with an initial investment of $9,000. The key to a problem like this is taking the information that we've been given and plugging it into our formula that we've also been given. So we know that the amount that I want to end up with in the account is $15,000. We also know that the principal, the amount I started with, is $9,000. We want to know what the interest rate is, so that's not something that we know yet. I'll just call it R. And we know that the time is going to be 2 years. Let's plug all that information into the formula. That tells me I've got $15,000 as my amount in the account, and that equals 9,000 times 1 plus the rate, which I don't know, squared. Now that we've plugged in all the information that we know, let's step back and look at what we have. We have an equation with R in it and a thing that's being squared. We can solve this using the square root method. The first step is going to be to divide both sides by 9,000 to get the squared thing by itself. Dividing both sides by 9,000 gives me, on this side, this fraction will reduce to 5/3. On the other side, I have 1 plus R quantity squared. Now I'm ready to use the square root property. I've got something being squared on this side, and I've got a number on the other side. I'll take the square root of both sides. For now, I'm going to leave this as the square root of 5/3 equals 1 plus R. Now to get the R by itself, all I need to do is subtract 1. That gives me negative 1 plus or minus the square root of 5/3 equals R. Now, that's a perfectly fine answer, except that the question asked what interest rate would I need. And I'm not going to go into a bank and ask if I can get an interest rate of -1 plus or minus the square root of 5/3. This is a good opportunity to use our calculators to get a nice decimal approximation for these two answers. Let's go ahead and write down what the two possibilities are. -1 plus the square root of 5/3 and -1 minus the square root of 5/3. We'll go ahead, grab a calculator, and plug that in. I'll start with -1 plus the square root of 5/3. And that gives me about 0.29. Now I'll go on to my other one, -1 minus the square root of 5/3, which gives me -2.29. Now let's look at these two answers. We're looking for an interest rate. This 0.29 decimal translates to 29% as an interest rate. However, this -2.29, we're not going to ever have a negative interest rate, so we can ignore that answer. This is the answer that we're interested in. In order for my $9,000 to grow to $15,000 over 2 years, even with compound interest, I would need a 29% interest rate. Our next example comes from physics. Neglecting air resistance, the distance in feet that a free-falling object travels is always given by this equation. Turns out the only thing that matters is how long it's been falling, which I think is really kind of neat that the mass of the object doesn't matter. All that matters is how long it's been falling, and that's our t squared. The Eiffel Tower is 986 feet tall. Let's figure out how long it will take an object to fall all that way from the top of the Eiffel Tower to the ground. Now, the distance here is my output, so I'm going to put 986 in for the distance. I don't know what the time is, but I can solve this for t. I'm going to start by dividing both sides by 16 to get the t squared by itself. Now, I know that my ultimate answer is going to be in seconds, and I'm probably going to want a nice decimal approximation anyways. So I'm going to leave this as 61.625 equals t squared. And then I can go ahead and take the square root of both sides to find out what my t is. The square root of 61.625 is about 7.85. So t is plus or minus 7.85 seconds. Now, only one of those two answers actually makes sense in this context. It's not going to take -7.85 seconds for the object to fall. So I'm going to go with the time for something to fall from the top of the Eiffel Tower to the ground is 7.85 seconds, almost 8 seconds. It's kind of a long time if you count it all. Anyway, that section wraps it up for section 8.1. Happy studying!